Oh, I didn't see you guys there. My name is... Get back to you guys next time. First off, Newton's first law explains the object in motion staying in motion and vice versa. So if the ball is not moving, it will not move until an unbalanced force is acted on. It's such as someone dribbling it.
Newton's second law explains that the acceleration of an object is directly proportional to the unbalanced force acting on it and inversely proportional to the object's mass. When Dalen shoots the ball with a mass of 0.61 kilograms, he shoots it with a force of 2.77 newtons.
Newton's third law explains that for every applied force, there is an equal and opposite force. So when Dalen shoots the ball, his applied force is transferred to the ball, which causes it to move.
Applied 15.84 joules to work when he shot the free throw. Since he applied 2.77 newtons of force, he did that in a distance of 5.72 meters, and we're able to calculate how much work he used.
We were also able to calculate how much power Dalen used. To find power, you divide work over time. Dalen's work was 15.84 joules, and he shot a free throw in 1.12 seconds. His total power was 14.14 watts.
The clip of Dalen dropping a basketball. We are going to solve for PE of the basketball. He's holding up the basketball that has a mass of 0.61 kilograms. At the height of 1 meter, while he is holding the ball, it has potential energy of 5.97 joules.
Dalen is shooting a free throw. We are going to solve for kinetic energy. The weight of the basketball is 0.61 kilograms, and the velocity of the ball while in the air was 5.66 meters per second. After we calculated it, the kinetic energy is 9.77 joules. When Dalen ran to do a layup, his feet had friction against the blacktop, and the friction caused Dalen to miss a shot, which is not often, you know what I mean? Oh my god!
And also find out how much gravity was used to bring the ball back down in the clip of Dalen shooting the three-pointer. We used the mass of the ball, which is 0.61 kilograms, multiplied by gravity acceleration, which is 9.8 meters per second, and we get 5.978 joules.
Physics!
We can also use the clip of Dalen dropping the ball to find the time it took for the ball to fall. He dropped the ball from 1 meter, and since it was not originally moving, the velocity is 0 meters per second. The gravity acceleration is negative 9.8 meters per second because it is pulling it down. From our calculations, we found out that it took 2.42 seconds for the ball to fall.
Momentum could be calculated by using the before and after mass and velocity and seeing how much has changed. We will find out that the velocity of how much Dalen moved after the collision. Kiara is 52 kilograms and moved 0.85 meters per second. Dalen is 63 kilograms and moved negative 1.1 meters per second. After the collision, Kiara moved 1.5 meters per second, and now we need to find out Dalen's velocity. Dalen's velocity was calculated to be negative 1.63 meters per second. When the collision happens, their energy is transferred into one another.
Clip, we can see the angles and velocities of projectiles. Dalen is shooting the basketball at an angle of 45 degrees. It has a horizontal velocity of 2 meters per second and the vertical velocity of 3 meters per second.
I'm not finished.
Velocity, fast track. You know that friction, got that. You know the ball, I passed that. Studio, we got that. What the? I'm Lil Dalen, I don't think you want no action. Yeah, basketball, no, I'm